All right, so we're in Journal 34 here, and we're going to start off with practicing synthetic division again, where we're taking a polynomial and we're dividing it with a factor, and we got to figure out if there's going to be a remainder or not. So we learned last time that basically when you want to divide a polynomial with a factor, you use something called synthetic division, where you have to make this box. And inside this box, you're going to put in the value of when you set this equal to 0, when you set the thing you're dividing by to 0. So if you were to set this factor, x plus 3 equal to 0, you have to solve for x, and so that one's not too bad. Basically, you would just subtract 3, and so x had to have been negative 3. So negative 3 goes in this box, and then outside of this box, you have to figure out what are you dividing by and what's the highest power. So you're dividing into x third plus 2x plus 30. So the highest power here is 3. So that tells me that you're going to have the labels x to the third, x squared, x to the first, and the constant. Make sure that you show all of the x to the constant. So what I mean is if your power is to the third power, you need to show every increment of x. So you're going to decrease the power until you reach the constant. And then underneath it, you need to write the coefficients. So in this case here, you have a 1 in front of x cubed, so a 1 underneath it. You don't have an x squared. Notice you don't have an x squared here. So if you don't have that term representing, you put a 0 there for the coefficient, because 0 times x squared makes it disappear, which is why it's not there. And then you have a 2 in front of the x to the first power, so I'm going to write 2 underneath. And then you have a 30 for the constant. Now from here, to use synthetic division, you always bring down the first number, and so this number always gets brought down, and then the numbers underneath or behind, like under the line, will always get multiplied by the number in the box. So 1 times negative 3 gives me negative 3. And then you always want to add your rows together. So basically 0 plus negative 3 gives me negative 3. Negative 3 times negative 3 gives me a positive 9. 2 plus 9 gives me 11, and 11 times negative 3 gives me negative 3. If I add 30 with negative 3, I get negative 3. And it looks like I have a remainder. So here is my remainder. And so it looks like my, in this case, the next number is my constant, x to the first, and x squared. So basically, your first number is always your remainder. Afterwards, it's the constant. Then x to the first, x squared, until you run out of digits. So in this case, my equation here is, keep in mind, these numbers are the coefficients in front of your variables. So you have 1x squared minus 3x plus 11, and then the remainder is a minus 3, so minus 3 over whatever you divided by, which was this x plus 1. So the remainder is always a number over what you divide. So in this case, x plus 3. So here is my quotient, or basically what I got after I divided this polynomial with x plus 3. And there we go. We have found our solution. Okay, so in the next slide here, we're going to talk about factors and how to test if something is a factor or not. Okay, so this is just the idea of factors in general. So you don't really need any algebra 2 here to figure this part out, just some elementary math. So basically what I'm asking you guys is to test if 8 is a factor of 104. So factors are basically saying, like, what numbers multiply to give you another number. Well, if I want to know if 8 is a factor of 104, I could just take 104 and divide it by 8, right? Because if it divides evenly, then that means that it's a factor. So in this case, 104 divided by 8 gives me 13. And so this tells me that 8 is a factor Because I actually divided that evenly and got 13. I didn't have any remainders. So since there's no remainder, that means that, well, it is a factor. Because there's no leftover numbers, so it's a factor. If we were to test this one out, it's asking if 8's a factor of, 110. Oops. And so if I were to divide 110 by 8, I actually get something like 3.75. And so this decimal is telling me it's not dividing evenly. So that tells me that 8 is not a factor of at least 1010 because there is a remainder. So if your remainder basically is not 0, then that means you have a remainder and it's not a factor because it didn't divide evenly. You have leftover numbers. So what we're going to be doing is we're going to be taking a polynomial and we'll be dividing it by a factor and seeing if it is a factor of that polynomial if it divides evenly or if the remainder is 0. So let's do a couple examples here to test out if this factor, x minus 3, is a factor of this polynomial. So what I have to do is basically divide this into this polynomial to test that out. So if I want to divide, I have to use synthetic. Since I'm using this as, like, this is being divided into here, if I were to set this equal to 0, it looks like my x here has to be positive 3, right? Remember what I said before? A quick way to figure out what goes in the box is just to flip the sign for this factor. So if that's negative 3, this is going to be positive 3. Or you could just solve for x like what we did here, and we also got a positive 3. So in this case, the factor here is x to the third is the highest power, then second, x first, and then your constant. So underneath it, I'm going to have my coefficients, so it looks like a 1, a 4, a negative 15, and a negative 8. I always bring down the first number, so that's 1. 1 times 3 gives me 3, and then I always add afterwards. So 4 plus 3 gives me 7. Oops, let me do 7, regular green. 7 times 3 gives me 21, positive. Negative 15 plus 21 gives me 6. And then 6 times 3 gives me positive 18. If I add, the remainder here is 0. So I did get a remainder of 0. So I can say that this x minus 3 is a factor. So because it is a factor, so let me just write this here for a moment. So because since the remainder is 0, x minus 3 is a factor. That's just because if you got 0, that means you don't have any leftovers. So this divided into it evenly. Now, if that's the case, that means that this here is one of your factors. So if you wanted to figure out the other factors, well, what is the equation left over is what we're going to try to figure out next. So this is the constant, x to first, then x squared. So what you really have here is 1x squared, or just x squared, plus 7x, plus 6. And so this is one of the factors, and then you already stated that x minus 3 is one of the factors, since the remainder was 0. And so if I want to know what the factors of this equation is, well, I already have one of them. Also notice that this power here, the highest power here, is 3, which tells me that I should have 3 factors. So in this case, I have 1. This here is a quadratic, or x squared, so I could factor this guy. And that would make it 6 and 1. If I were to try to factor 6 and 1 might work here. So if I factor this, I would have positive 6, positive 1, and they both need to be plus signs because 6 times 1 gives me 6, 6 plus 1 gives me 7. So in this case, I have x plus 6, x plus 1, and x minus 3 as my factors. And since this is x to the third power, I should have 3 factors, and I do. And so here they are, my 3 factors. So basically what we did here is we're going to test out, well, we want to factor this here. And in order to factor, basically I'm going to give you one factor that you're going to divide into to check if it is a factor. So the way you check is to see if you use synthetic division and get a remainder of 0. If it is, that means that's one of your factors. So if this is x to the third power, that means you still have 2 more factors to go. So in this case, using what you divided, so after you divide it, you have a, an expression. So in here's your equation, and so you're going to factor that and get your other 2 factors. And so now I have all the factors. This one, we want to check if x plus 3 is a factor of this polynomial. It looks like the same polynomial again. So I'm just going to check by using synthetic division. And since this is plus 3, in my box I need a negative 3. And so then from here, I'm just going to create my outline. And underneath, I need my coefficients. Since that's a 1, 4, negative 15, negative 18. Same as last time. I always bring down the first number. Then multiply the number in the bottom with the number in the box, which is negative 3. And then I add the rows together. So 4 plus negative 3 gives me 1. 1 times negative 3 gives me negative 3. So that's negative 18. Negative 18 times 3 gives me positive 54, and if I add, that's actually 36. So this time around, I do have a remainder, which tells me, well, basically since there is a remainder, that tells me that the factor that I divided with, x plus 3, is not a factor, So that tells me that I need to stop here because I can no longer factor this because the remainders here is not 0. So this would be impossible to factor. All right, let's get into the homework packet next. I'm going to be doing homework pages 4, and I'm going to do problem 2 here in a moment. So this is page 4 on packet 7, and this is number 2 on that page. So number 2, what it's asking you to do in this page is you have to find the factors. So you're given a factor, x plus 1 in this case, and you have to find all of them. So first off, I want you to recognize what's the highest power here. So the highest power here is 3, which tells me that you should have 3 factors, okay? So in this case, we're going to start using synthetic division. And in this box, since that's x plus 1, in here should be negative 1. Since that's a plus 1, that will be a negative 1. Remember, we flip the signs when we're given a factor. And then in this case, since our highest power is to the third power, I'm going to make my labels. And underneath it, I need my coefficient. So it looks like these first 2 are both 1s. I have a negative 16 and then another negative 16. So first off, we always bring down the first number. We multiply the bottom number with the number in the box. So that's negative 1. And then we add. So that's 0. 0 times negative 1 is 0. And then negative 16 plus 0 gives me negative 6. Negative 6 times negative 1 gives me positive 16. Sorry, did I say negative 6? I meant to say negative 16 times negative 1 gives me positive 16. And if I add, I get a remainder of 0. Nice. So that tells me that, x plus 1 is a factor. So that means I'll be able to use this later to state as a factor. That means that I actually have 2 more factors that I need to find. And turns out this equation here will reveal to me what the other 2 factors are. So remember, this is your constant, your x, then your x squared. So what you really have here is, looks like 1x squared. Since this is a 0, that means I don't have to write this x. If I multiply, that goes away. And then my constant here is negative 16. Now, since I already know that 1 here, that there's a 1 in front of this x squared, that's kind of redundant, so I'm going to erase that, since the coefficient is always 1 if you don't even write it. And if I write it out this way, I can see that I have this factor and then the one that I was given, so x plus 1. I'm just going to shoot this guy down since I already know that's one of my factors. But you can see that this is a quadratic, so you can factor this to get 2 more. So notice how this is a binomial. So if you have negative 16 and that's x squared, we know that 4 times 4 gives you gives 16. So if you were to factor this here, you got to drop down your x's. You need a 4 and a 4. To make a negative 16, one of them needs to be negative, the other needs to be positive. Because when you take negative 4 multiplied by positive 4, you get negative 16. When you add them, they cancel, which is why there's not a middle term here. So in this case, we have, x minus 4, x plus 4, and then x plus 1. I'm just going to bring it down. And it looks like this here is our 3 factors that we're working with. So in this case, we're done. We just want a factor. All right, let's do one more of these together. So this time you need to factor this guy here. Oops, my bad. And in order to factor this piece here, they gave you one of the factors that you have to test whether it is a factor. So again, the highest power here is 3, so we need 3 factors. So I'm going to test out x minus 1. So in my box, I'll need a positive 1, it looks like, since that's a negative 1. So I'll put a positive 1 in. This is x to the third, x squared, x, and then the constant. Underneath it is a 3, a 10, a negative 1, and then a negative 12. And so 3, 10, negative 1, negative 12. I'm going to bring down the first number. So I have 3. 3 times 1 is 3. And then I'm going to add. And 10 plus 3 gives me 13. 13 times 1 gives me 13. If I add these two, I get 12. 12 times negative 1 gives me, well, positive 12. So if I add these two here, I just get 0. So this is my remainder, my constant, my x, and my x squared. So this tells me since the remainder here is 0, then x minus 1 is one of my factors that I get to use, which is nice. But in here, I also have another equation that I do need to factor. I have a 3x squared plus 13x plus 12 that I will need to factor. So in order to factor this guy, I do need to think about this for a moment. To factor something that has a number in front of x squared, this is when you have to use slide and divide. So what I'm going to do here, I'm going to put the equation on this side so I can work it out separately, and then I'll bring back the factors when I solve for them. So slide and divide says that you're going to take your number in front of x squared and you're going to slide it over to the constant, or the number at the end. And so that means you have x squared plus 13x plus 3 times 12 is 36. And then you're going to factor like normal, so x, x, and then two numbers that make 36 but add to give you 13, maybe 9 and 4, right? 9 times 4 gives me 36, but 9 plus 4 gives me 13. So this works out. So I need a positive 9 and a positive 4. But when we slide, we also have to divide by the number that we multiplied. So if we multiply by the 3, I need to divide out 3. And you can see that the first one divides nicely. 9 divided by 3 is 3. But this one doesn't. So this 3 gets put in front of the x when it doesn't divide nicely. And so here are my other two factors that I'm going to stick over here. So it looks like my factors are x plus 3, 3x plus 4, and x minus 1 that I'll just bring down from before. And so these are my 3 factors. And I'm done. So sometimes if you have a number in front of x squared, you can use slide and divide and to help you find the other two factors. All right. Hopefully this video helps you with your homework.